How do you conduct a bias audit? This is a question that I get probably more often than any other question, probably because we're a company that audits systems, particularly for bias. This is something that is required by law in lots of places. And so we get this question in our training program. We get it from potential clients. And so I want to walk through in a really qualitative way the general framework for thinking about testing AI systems for bias. And it's going to be the same as you would test any other algorithm for bias. And so let's frame this a little bit. What do we mean by bias? And so typically, what most people are talking about when they're talking about bias is very kind of narrow performance differences of a particular AI system depending on some kind of protected category or protected class variable. What that means is things like race, gender, ethnicity, socioeconomic status, disability status, things that are protected by law, where anti-discrimination law matters. So, but it's useful to think about bias in a kind of broader sense, because if you can think about it in a broader sense, a lot of the kind of testing that I'm about to describe can cover all kinds of testing and evaluation that are related actually to verification and validation in particular. And so let's think a little bit more broadly about that. Typically, the way I like to think about bias and the way we teach in our class is that you can pick a performance metric. So pick any metric you want. It could be something like accuracy. It could be something that has to do with classification. So maybe it's the false positive rate, maybe it's the false negative rate, the true positive rate, things like this. That would be like in a confusion matrix. It could be other kinds of metrics that you might come up with that have to do with robustness or something like that. So pick any kind of performance metric that is relevant for your AI system, right? For the performance of that AI system. Then ask yourself the question, how does that metric perform in different parts of the input parameter space? So what do I mean by that? You have an AI system that, let's use like a hiring algorithm, for example. So something that might match a resume to a job description. We see many of these in the HR context. Think about that metric in terms of bias when the input parameter spaces would be basically all the potential people that would submit a CV for a particular job or a set of jobs. What you want to think about is, how does the accuracy of that, let's say, whatever the metric is, change as you change the type of person that is applying. So if we're thinking about bias in the discrimination sense, how does that metric vary across race? How does it vary across gender? How does it vary across other protected categories? So that's one way of thinking about it. And so the metric itself might be something like selection rate, which is very common, which means, what's the probability that if you apply for a job, you're going to get selected. And you would look at that selection rate as a function of race or a function of gender. That's the classic sort of bias testing that you might do. However, you don't have to think about that. You can think about the performance as a function of geography. You can think about it as a function of the type of job description. So maybe industry, the way the job description is described, the sections that the job description has in it, right? That's also looking for bias. This is a systematic difference of a particular metric in a particular part as you go from one part of the parameter space to the other. Okay. So that's the general idea. So let's apply it to something else. You could imagine bias in a different way. So let's say I have a facial recognition algorithm. So this is an algorithm which takes in images and an image presumably of a person, and it's going to try to do something with that. So maybe it's trying to identify whether this person in the image is a person in a different image, or maybe doing some kind of other kind of facial analysis, some emotion detection, or there's all sorts of different things you can do. Think about a particular metric. So something like false positive rate. So maybe I that's the rate at which I sort of misclassify a person. I say a person in this image is the same person as this other image, but they're actually not, right? That's a metric. And then what you could do is, like I had mentioned before, you could look at the differences in that metric, the false positive rate, across different parts of the parameter space. So you could do race, gender, age, that sort of thing. But you could also do it according to the setting of the image. So what kind of, is this in a room like this? Are these images in from outside? So maybe it's in a parking garage, or maybe it's out on the street, and different kinds of environments. If it's outside, maybe it's foggy, maybe it's raining, maybe the angle is different. So how does it change if I have something that's like a street view versus something that's a little bit higher? Lighting is another part of the parameter space. Low lighting versus really good lighting. The size of the person's face in the image, right? If the person's farther away versus closer. So all of these things are exactly, you measure them in exactly the same way as you would measure sort of ordinary bias that you think of in terms of discrimination, but they are simply testing the systematic shift in some performance metric across different parts of the parameter space. And this is related fundamentally to the overall functioning of the system. How good of a system is this, and is it going to work when you want it to work? And those of you who've taken our courses, you know that we have this concept called the CEDA narrative, which is the context, input, decision, action narrative. And we use this as sort of a precursor or a way of describing an AI system that includes sort of the context in which you want that system to be operating, the types of inputs you expect in that system, the way it makes that decision. So the decision procedure, which is really the algorithm, and then the action that gets taken in the world. So what comes out of it and what action could actually impact somebody. And the context here is really important, because if you've defined well what your context is, what the typical operating parameters are, what part of that parameter space you expect the system to be functioning in, then you can start measuring the systematic difference between different parts of that parameter space and the metrics that you're measuring, metrics that are relevant for risk or relevant for getting the value from the system. And so even though bias typically is talked about in terms of discrimination, and that is the sort of the primary worry for many, many people, it's a useful way of thinking in general about testing the performance and the validity in some cases of a system, and the system in the context of which it's supposed to be used. I think this is sort of a general overview, and I'd like to dig in a little bit into how you might actually start partitioning up a data set into those different parameters.